This week, obviously, as we celebrate Earth, we reflect on one of Earth's many benefits, and that is plants. While toddlers may not fully appreciate their veggies, space crews are always excited when a spacecraft docks bringing fresh fruits and vegetables from Earth. And the SpaceX Dragon that arrived recently has delivered a new experiment that's designed to help space crews grow their own veggies on board. This would be essential, obviously, for long, deep space missions. Jessica Egan with the POIC there at the Marshall Space Flight Center spoke with a representative of the Orbital Technologies about the Veggies project.
The Veggie is a food production system that will be flown to space station at the end of this year to provide supplemental nourishment to the astronauts and grow vegetables and such as lettuce and tomatoes and radishes and a full dietary menu is capable on this production system. The hardware consists of an LED lid with lighting underneath it, with a bellows system and a skeleton that holds that all together. We have root maps with seeds inside of them, and it's an accordion type system that will raise as the plants grow. And the lighting system is only the light that is necessary for plants to live, and it's a 24/7 cycle, so there is no nighttime, so it grows very quickly and we turn the crops very quickly.
So why is this unique?
Well, it's unique in a way that it's very interactive to the astronauts. They can touch it, feel it, have the goodness. There's been plant science up there, but it's all been enclosed and very controlled environment. This environment is outside. It's very, very interactive to the astronauts. We are very interested in the environmental control and life support systems. With this plant technology, ISS with zero-G, we're able to take and assess what the plants do in the grow, and what we're trying to do is capture the humidity, condensation, and recycle it back into the environmental control systems. So in this effort to resource utilize as much as possible. Now, it's critical to do this at zero-G, because if we're going to do long duration space, Moon, Mars, this has to be done, and we have to recover and take those resources as far as they can. We have commercialized a lot of this technology with the LED lighting systems and wavelengths of lights. We're actually building full rooms of plant growth rooms for customers, universities, things like that. The applications for this and commercialization for this is endless. You know, the extreme environment places where we can grow year-round within these systems and produce a lot of food for people that wouldn't normally get that fresh food. We have customers, commercial as well as government, that want to put hotels into space, that want to put colonize the moon, eventually Mars, and to do that, this is the starting period, and ISS gives us that platform, which is a wonderful platform.
The first batch will be tested thoroughly to ensure safety and nutrition, but the goal is to eventually allow International Space Station astronauts to eat food grown right there on the station.